Good morning, everyone. It's our first day of Calc 3, so I thought I'd give you an introduction to it. We'll nip over later and look at the Canvas site and at WebAssign. The good news is, well, for a lot of you, the good news is you know how I do things, so you're not going to be too shocked about the methods and the way I approach things. But for the new people, it's worth it for them to see it. Everything you need to know is in Canvas. Just click on syllabus and you can see, you know, a kind of big summary. And when you go and you look at our first home Canvas page, it tells you pretty much everything. And the fact that you're here already knows that you know how to do the zoom bit. Hopefully you've all figured out WebAssign. I had a couple of emails, I don't know what happened, but some of you weren't getting in and you were using the wrong class key. Hopefully that's sorted itself out now. And we'll look at WebAssign a little bit today as well. Well, let's get started. What's Calc 3 about? Well, let's start with what Calc 1 and 2 are about. I mean, if I was trying to summarize Calc 1, I would say it was basically differentiation in one word. Which is, how do you find derivatives of functions? Right, different techniques for doing it. You know, like product rule and quotient rule and chain rule and so on. And then once you know how to differentiate things, what can you do with them? So you can use it to find slopes of tangent lines and rates of change and where the max and mins of functions are and all sorts of cool stuff like that. And then what would Calc 2 be then? Well, in a single word, Calc 2 is integration. If you think back to what Calc 2 was, mostly wasn't it about how do you find antiderivatives? Right? How do you find integrals of functions? And things like power rule and U subs and integration by parts and trig substitution and all that good stuff, right? How do you find integrals? U subs, for instance. And then once you know how to do that, what can you do with integrals? Well, you can use them to find areas under curves, area between curves, volumes of revolution, what else? Distance traveled, surface area, arc length, and lots of other cool stuff, right? That was mostly what Calc 2 was about. So you might think, what the heck is Calc 3 about? Well, the bad news is that Calc 3 can't be described by a single word. I think the best way of deciding or to try to tell you what Calc 3 is about is to really say it's a lot of cool stuff. We are just going to find out how to do a lot of cool different stuff. Because the first 4 weeks, we are going to be dealing with things called sequences and series. And then after that, we're going to deal with vectors. And then after that, we are going to deal with space curves. And then we'll finish with multivariate functions and partial derivatives. And there's not an awful lot of A becomes B, becomes C, becomes D. They're almost like little pieces of knowledge on their own. So sequences and series won't help you to do vectors. And vectors won't help you to do partial derivatives, right? So don't try and make a connection between these cool things that we're going to do. Just think of them as little pieces of nice, useful information, but they're kind of on their own. So Calc 3 was kind of where we put all the other cool stuff, but we couldn't figure out, or we didn't have enough room to put it anywhere else. So it doesn't have a nice flow to it, and you just have to live with that. Actually, Calc 4, the one after this, has a very nice flow. Calc flow is how do you integrate and differentiate multivariate functions? So Calc 4 is very easy to describe what it's about. Calc 3, on the other hand, not so much. So I kind of, what's that? That's like a kind of a warning sticker. Don't expect continuity in these subjects, right? These topics. They're almost isolated. I could virtually shuffle them, well, 3 out of the 4 anyway, and put them in any order I liked, and it wouldn't make any difference. Right? You don't need to know one thing from A to be able to go on and do B, right? It doesn't work that way. So let's start with chapter 11, which is sequences and series. And we'll start with the first section, sequences. I'll start off with a definition. A sequence is a list of numbers that has a predictable pattern. And chapter 11, which is called Sequences and Series, has, I think, something like 14 sections in it. So it's a big chunk of work. That's why it's going to take 4 weeks to do. But only the first one deals with sequences. And the other 13 deal with series. So go figure. It's not an even balance. Well, what do I mean? A sequence is a list of numbers that has a predictable pattern. Here's an example of a sequence. Very simple one. One of the ways to write sequences down is you write the first 3, 4 terms, like I've done here. And then you put ... and hopefully people can see the predictable pattern. If you can, shouldn't you be able to predict what the next number should be? No trick questions here, but just so that we can get used to answering questions. What is the next number?
9.
How would you describe to someone else how you figured out it was 9? What did you do? Or how did you know, I guess?
Just add 2.
Right. That's one way of looking at it. Just add 2.
All the numbers are odd.
There's another way of looking at it. Right, different ways of looking at it, but right, makes sense. Right. How about this sequence? Any volunteers for the next number?
They're all squared.
Right, so what would the next number be?
25. Is it you add the 2 numbers together to get the next value?
So what would the next number be according to what you just said?
13.
Correct. So if you're wondering what you're saying there, I'm saying you didn't say it well because you did.
Yeah.
You add those together, you get 2. You add the last 2 numbers together, you get 3. You add the last 2 numbers together, you get 5. Right? You add the next 2 numbers, you get 8. You add those 2 numbers, you get 13. So can you see that a sequence is a list of numbers, right? With some predictable pattern. You should be able to predict uniquely the next number, agreed? If it's a good sequence. So what wouldn't qualify as a sequence? That would not qualify as a sequence. It would qualify as a list of numbers, but not a sequence. And the reason for that is that there is no predictable pattern. Would you agree the next number could be anything? And the reason for that is I just randomly wrote down the first 5 digits that come into my head. So that's really what makes a sequence a sequence. It has a predictability about it, right? There is a pattern there that allows us to predict the next number and then the one after that, and so on. So we're going to introduce some notation. Here's some notation. Oh, I'll use a new sequence to do it. How about this sequence? 1, 4, 7, 10. Right. A1 is called 1. A2 is 4. A3 is 7. And A4 is 10. Now, all we're doing here is labeling the sequence. So a general sequence, right, one that you don't know really anything very much about, could be written down as A1, A2, A3, dot, dot, dot. Okay, so if I went and said to you, for this sequence, what would A10 be, right? Wouldn't you go and figure out eventually, after a little bit of work, what the 10th number would be? Agreed? I mean, couldn't you eventually get the 10th number? Well, does anybody know what the pattern here is that makes this predictable?
+3.
Right, so couldn't I just add 3? That's 13, 16, 19, 22, 25, 28, 31, 33. So it would be 33, I believe. So far, so good. Now, it would be really helpful if you were given a formula for a sequence, and you very often are. There is a formula for a sequence, AN equals 3 plus 2n. If I gave you that formula, you should be able to do quite a few things. First thing, shouldn't you be able to write down the first 4 numbers in the sequence, probably in your head? Right. So the first 4 numbers would be A1, A2, A3, and A4. Right. A1, 3 plus 2 gets you 5. A2, 3 plus 4 gets you 7, 9, 11. So as a sequence, it would be 5, 7, 9, and 11, and so on, right? So you could, if you are given a formula at least, couldn't you write down the first 10 numbers in the sequence if you wanted to? Agreed? Now, I could also find the 100th number, but I wouldn't need to get the first 99 and then get the 100, right? I wouldn't need to do it that way, because if you've got a formula, can't you just replace the n with 100? And you can get that guy. So if you tell me a formula, which is a very, very useful thing to know, if you tell me that, can't I get the first 4 or 5 terms of the sequence very easily? It's not a trick question, right? Just plug in 1, plug in 2, plug in 3, plug in 4. Can't I get the 100th number or the 1000th number in the sequence with just a single calculation? And lastly, you can answer this question. What term of the sequence is 63? I don't need to know the answer, but you might be able to do it if you in your head. That's nice. But how would you find the answer?
So
Use simple algebra and just plug it in.
Well, if you mean that, I agree with you. When I mean the sequence is 63, I'm not asking you for the 63rd term in the sequence. I'm asking you which one of these is 63. So can you see that's what I'm getting at, right? Now, quick subtraction, followed by a division. And I can now tell you that the 30th number in the sequence was 63. So if I give you a formula for a sequence, do you feel comfortable about you can answer each one of these questions without too much trouble? Right. Now, if the formula is ugly or just messy or whatever, wouldn't it be nice if there was a way that you could let your calculator answer this question, right? The first 5 numbers in a sequence. So imagine I had a sequence and it was 3 times 1.1 to the power of n take away 1. Which you get as a pretty ugly calculation, right? And I would like to get the first 5 terms. Now, I could simply just 3 times 1.1 to the power of 0, then to power of 1, power of 2. I could do it that way. But there is another way that you can do it. So let me show you, hopefully, how you can do it on the calculator. Right, you should hopefully be looking at the emulator, which I have on Canvas if you want to go looking for this guy, for the TI-84 if you don't have your own. And I'll switch the thing on. It's on, yes it is. And where shall we go here? Well, I'll show you the basic way of doing it. There is another way. If I just go in here and do y equals, and I go 3 times, I don't have a lot, but I'm putting in a bracket just for safety. And then I'll do a power. I think I hit the power, did I? There we are, it's better. And it's n minus 1, so it's going to go and call it x minus 1. And if I now go to table setup and I start at 0 and I go up in 1s, which this is already set up, I can now do second table. And we want to start at 1. So the first answer is 3.3. 3.63. 3.993. And last but not least, 4.3923. So you see that you can type in essentially the formula. The only difference is, won't you use an X where an N would go? And then you can just use the table feature of your calculator. Because there are some homework questions that say find the first 5 terms of this sequence or that sequence. And you can certainly do 5 calculations if you want, but I think this might be a little bit easier if the calculations are ugly.
Could you show the process from that part on again?
Sure. So you put this piece in, you set up the table, start at 1 there, and make delta 1. So that's the only 2 things you need to make sure. Make that one and make that one. That's the table setup finished. And then you go blue button table. There we go. And there's all the answers. A1, A2, A3, A4, A5, and you keep going.
Thank you.
So let me return back to here. So are we comfortable that you know what a sequence is now? Right? It's just a list of numbers that has some predictable pattern to it. And that if I give you a formula, do you feel comfortable about finding the first 4 or 5 terms in the sequence finding the 100th term in the sequence, finding out which term would be 63. So all of those types of questions you could do relatively quickly. Right? Now, if it's a one-off question, like A100 or A200, you know, that kind of question, then I think what you should really do is just a single calculation, right? So if I wanted to do, not that I'm going to try it because I know the answer would be huge, but if I wanted to find the 100th number in this sequence, wouldn't it be 3 times 1.1 to the power of 99? And you can imagine that would be pretty massively ugly and big, but it's doable. Make sure that when you do WebAssign, that if it says to 3 decimal places that you round off correctly, because sometimes it can be twitchy if you give it 6 and it only wanted 4. Right, are there any questions up to this point, or do you feel comfortable about what we've done? Okay, so let me introduce you now to the fact that there isn't one kind of sequence in the world, there are 2. There are 2 basic types of sequences. The first one are formula-based. We've actually done 2 examples of that. These are sequences where you can write down a formula, right, for the nth term. If you can write a single formula, an equals some function of n, then you're looking at a formula-based sequence. And the second type of sequence is called a recursive-based one. Now let me show you what those guys look like. Here is an example of what a recursive-based sequence would look like. It also has a formula, but it's not an, right, the nth term in the sequence, and then a function of n. It says an plus 1, but weird, and it's 0.3 an add 5. And the reason this is a recursive-based thing is that what this formula does is it tells you how to get the next number in the sequence. So you are always given a seed. So the first number in this sequence is 10. Now, if I want to get the second number in the sequence, right, the next number in the sequence, it's 0.3, the previous number, add 5. So it's going to be 0.3 times A1, add 5, 0.3 times 10, add 5, and that ends up being 8. Now, if I want to get the third number in the sequence, it's 0.3 times the previous number, add 5, 0.3 times 8, add 5, and this guy is, I believe, 7.4. Have you noticed that in the recursive-based formula, if you wanted to get the 10th number, don't you have to first find the other 9? Right? And there's no way of avoiding that. But they're not going to ask you much except to find the first 4 or 5 terms. So there isn't really a very obvious shortcut. I'm not even going to try and show you how to do it in a calculator anyway. It's so messy, it's not worth the effort to learn. Just do it the slow way, right? Just take it, get the answer. Take it, get the answer, right? 4 or 5 times, boom, it's done. As long as you're careful, it'll be fine. You do not tend to get with these questions, what's the 100th term? Because you can imagine it's doable, but do you want to spend the next 5 hours getting the first 99 just so you can answer the 100th one? So they're not going to ask you that. And the same kind of thing is they're not going to ask you what term is 63, right? I mean, they could. Wouldn't you just keep going till you got to the answer that was 63 and stop? So they don't ask it because it's kind of time consuming and not very necessary. Now, recursive based can be, this one's a single recursive. Here's an even more interesting one. Now, what the heck is that trying to tell us? The next number in the sequence is the previous number plus the one that came before that one. Now, let's see what that looks like. A1 is 1, A2 is 1. Won't A3 be just A2 plus A1? 1 plus 1 gets you 2. Won't A4 be A3 plus A2? And won't A5 then be the 4th term plus the 3rd term? Now, if I write them down as a sequence, do you recognize that guy? Because we did him at the start of today. Here's a biggie. I don't know if anybody would even know this, but it amazed me. You might. Do you know that sequence is a very special sequence called after it?
At like the beginning was like the Fibonacci sequence.
It is. Well done. After an Italian, I believe, called Fibonacci. Fibonacci sequence. Very, very weird sequence. Has got lots of weird places that it just turns up. Do you know that certain trees and plants, you know, that branch and then the branches branch out and those little branches branch out again? Do you know there's a lot of plants who branch out on the Fibonacci sequence? Right, one gets you 2 sub-branches. The 2 sub-branches break into 3 little baby branches. Those 3, you know, like a bush. Fibonacci sequence. Do you know that if you take a Fibonacci sequence and you divide this term with that, then this with that, and this with that, you get another sequence, and that the limit of that sequence is the golden ratio? Which, if you don't know the golden ratio, it's a cool thing to look into. The Greeks knew about it. It was a ratio to width and height that is very pleasing to the eye architecturally. So a lot of the Greeks would build their temples to the ratio of the Fibonacci, the magic number, the golden ratio, I should say. And Fibonacci is used there. I think Fibonacci also appears in nuclear fission somewhere, where there's something to do with the way things break apart when they get hit in a cyclotron. Can be in a Fibonacci sequence. Some weird, very interesting sequences out there. If a sequence is useful or interesting, it'll be given a name. So let me give you some other sequences that have names to them. Remember the one where you kept on adding 2? Right, Ripken was doing that one, right? You added 2, you added 2. They are called arithmetic sequences. No particular reason, I'll change color here. Do you notice what I'm doing in that sequence? What would the next number be?
32.
32.
32. And that's called a geometric sequence. Shot in the dark, but somebody might know. Do you know what that sequence is called? It must have something to do with music because of its name. It's called a harmonic. So there are many, theoretically at least, there's an infinite number of sequences in the world. Only a few, like the Fibonacci or the harmonic, get their own names. The arithmetic and the geometric, there's a whole family of those. Can you add 5 each time, or add 2 each time, or take away 7 each time? Or multiply everybody by 2 or 4 or a half, or -3. So there's lots of geometric, there's lots of arithmetic, but there's really only one Fibonacci, a true Fibonacci at least, and one harmonic, a true harmonic. That's pretty cool stuff. Now, I'm going to, so I get my mouse pointer back, I'm going to spend a few minutes now changing subject, and we are now going to look, hopefully, at this guy here. This is our Canvas page. So let me spend a few moments talking about this because it's important. If you are new to this class, then there's lots of things that you don't know how I do or what I expect of you. So let me give you a quick summary. If you hit the syllabus, this tells you everything that you need to know. First, how you're going to contact me, email. Will you make sure that you use your official OC email? It just saves a whole load of things get put into the trash bin or the spam place and I never get to see them, or vice versa, right? And that includes, if you haven't already, when you join WebAssign, to do that one. Our office hours, there's fixed ones at 10 o'clock, but that may not suit you. But if you need to see me about homework or whatever, I'm going to have that set up as like a Zoom meeting that'll just be open and you just turn up, right? And you might have to join a queue just like if you physically turned up to my office, because I don't think, if someone's talking about issues, they might not want other people to hear, right? So it's not that I'm not there, but you might have to wait till it's your turn, right? But I will get to you, hopefully. So that's a little bit different. That might not work for you. You might have a class every single day at 10. Then you just do the usual of shoot me an email. And for instance, we could simply just wait to the end of this period and I'm free right after this class and just do it then, for example. Prerequisites, I'm allowed to change everything and anything I want because I might have to. Question? No? I don't think anybody in this class, but I've had 3 emails saying they had problems getting into WebAssign. Are you all comfortable? Maybe I should make this a little bit bigger. There you go. Are we all comfortable that that's our key to get into WebAssign and you've already joined up or will by the end of today? Here is a whole calendar of important dates. And here we go. Things are broken into 2-week chunks. In this class, the first 2 weeks are going to deal with 11.1 to 11.6, essentially the first half of chapter 11. And we're going to look at various sequences and series. And then there will be a test on Monday, and it will be from 1 to 150. So it's just a 1 hour test we're having. And then the next 2 weeks will be the rest of chapter 11. Homework is due on Sunday the 17th. And then in this case, it's going to be due on Sunday the 31st, midnight. Pretty much what I always do. Then you have a test, and that'll be on the second half of chapter 11. Then we have the next 2 weeks are dealing with chapter 12, which are basically vectors. So if you've done vectors before, you will find that this is really the same stuff. We just do 3-dimensional vectors rather than 2. Then we move on to the next 2 weeks where we do vector functions. And then we do multivariate functions, partial derivatives in particular. Our last test is on that Monday, and the final for us is on a Thursday, and it's from 10 till 1. So that's basically the next 11 weeks of your life, right? As far as Calc 3 is concerned. We feel comfortable about that. There's nothing too surprising. It's the way I do things. 2 weeks homework. Do not wait until Sunday the 17th, 11 p.m. to do all your homework. It does not end well. Do your homework as soon after as you can. For instance, although we haven't done a lot today, you actually do know enough today to do, I think, about the first 5 or 6 questions. Now, let's move on to hopefully WebAssign. Oh, I have to join up.
Before we continue, are the test time periods set in stone, or can be flexible?
It's taken during the class time, so it should be okay, because it's 50 minutes in the class period. So it's taking, I hope I put it down, it's taking place during 11 to 11:50, right? So it shouldn't interfere with anybody's time. If you have a class 12 and you have problems with the uploading it, we can arrange a different time. So it's not written in stone. Is that what you're thinking, Kathy?
No, it looks like you have it down as 1 on
Oh, just typo. My apologies. Typo. I better take a note of that so I can fix it. I had it as 1. Hey. Well, that's because I've got 2 calc classes that are calc 2 and the other one is 1. So guess what? That's why it's 1, I think. That's my excuse. Okay, let's get this thing up and running. Calc 3 for us. There we go. And going to student view. Okay, so this is what you should be looking at when you go to WebAssign. And essentially, down at the bottom here is your ebook, in case you know, it's helpful. Oh, good, I did that right. Just panicked for a minute. That's set up the way it should be. And as you can see, here are what is needed. And there it is, Sunday, midnight, right? Well, virtually midnight. We go. Now, if you haven't done WebAssign before, it should be set up that you get 3 shots and lots of help for every question. So if you do get stuck, use their help features. Do not, let me emphasize that again, do not do the ask your professor link or ask for extension link. They go somewhere into the ether, and I've never figured out how to get WebAssign to automatically send it directly to me. So I never actually see any of those requests. So it's not like I'm ignoring you. So if you come across an issue, you email me the usual old-fashioned way, and I'll find out what's going on. And I'll try and answer your questions or set up a Zoom meeting if it's a little bit more involved and I need to write things down. Awiko. Going to hit this and hopefully none crashes. There we go. If you've done WebAssign before, you know how it works. Classic question. Can you see here's a sequence written down in its usual formula way? Write down what the answers are. It looks to me, since there is no mention of decimal places, that you will need to make sure that these answers are written as -1/712, right? As exact values, not as nothing point 1, 2, 3, 4, 5, right? You probably would want to take these answers and just do them by hand because of that. Right? So do the top guy, do the bottom. It looks to me like the answer is going to be -1/3 plus a 9th, -1/27th plus 1/81st. That's fine. Can you see a recurrence situation here? Right. The next number is 5 times the previous number, take away 6. And the first number is 2. So you get that guy for free, right? Now, the next number then, won't it be 5 times 2 take away 6? Well, that's 10 take away 6. So I'm assuming the answer to that is 4. Right? Are we go with that kind of question? Here is another recurrence relation. Exact answer, so make sure you do fractions here. Here is a formula one, exact answers, do fractions. Here's a recurrence one. And that's pretty much all you know how to do right now. Do you notice you get a little guy over here? So if you want to write fractions, you go like this. And I know that this isn't the right answer, but can you see that's how you write fractions in? Right? You hit the little box, boom, and then this guy appears. Any questions? We comfortable about what's going on? Read the syllabus. Now, if I return back to Canvas, if you click on this link, there's a little difference to last time because I figured out how to do it now. The same link can be used for the entire week. So there's only one link for every one of these days. It's a little bit less hassle. If you go down here, although it's blank right now, every Zoom meeting we have will be linked here. And I should ask, so I'm asking right now, do I have your permission to put the Zoom lessons online for everyone to look at? If you do not feel comfortable with that, you will send me an email and I will, what will I do? I will try and omit you from the video so that there's no sign of you. That could be quite awkward. If I find that's too much work, I just won't do the videos. That'll be it. That's the only alternate I've got. So if you have an issue and you're entitled completely to have one, you tell me about it and I won't do them. Office hours are never put online, so you can have complete comforting knowing that whatever we do during an office hour, only me and you know about it, and that never gets published. If I again leave this and go to a different location, if you hit chapter 11, resources, in each of the sections, I have got some videos that you might want to look at. Randomly, if you click on this one and hit that guy, you see a video from I found useful. If someone comes across another video and said, I found this video to be really, really helpful when I was doing, insert topic here, shoot me a link to it and I can add it onto this so that you know, others can benefit from what you found. And if you find some of these videos are not helpful, and you know, the opposite of helpful, right? They made you more confused rather than help you. Tell me that as well, and I'll just remove the damn thing, right? But you know, these things get updated. Are we cool? Right. So there is going to be, in this link at the top, the Zoom lectures, provided I get your permission. And then this one here, there's going to be, there already is, other lectures that you can look at. Okay. I believe I've got Elizabeth Briggs did some really cool videos, and I've got some of her videos on this as well. If that is okay, can we now move back to sequences? Any questions?
Can we put a plug-in for e-tutoring?
Great. Kathy, you are, take the stage.
Sure, put me on the spot. So I actually work for the e-tutoring site. We do have calculus tutors, and the e-tutoring site is open, I think, from 5 in the morning till midnight. And the tutors aren't all from our school, but they're all there to help. You do want to make sure that you find a tutor that has calculus next to their name to guarantee that they can at least talk you through some of the work. And obviously, because of academic integrity, you're not going to be asking for help on tests or quizzes, but they can help you with your homework and help clarify things. They're not there to teach you. That's Donald's job. But they will help explain things differently if you need.
E-tutoring, the tutoring system is very, very helpful. So feel free to use that as a resource. There are links to e-tutoring, I believe, on the front Canvas page, right? The one that you go into before you go to my class. There is a link. Is it in the left-hand side, or I'm trying to remember where I saw it?
I think it's on the left-hand side. You also have it in college resources.
Right, so if you look at that link as well, I've actually got college resources in front of me, and it is.
Yeah.
If you look at college resources, you'll find a link to that. That is inside my Canvas site as well. So if you go inside that, you'll get it. So it's not hard, and it's called e-tutoring, and it's free, right? You've already paid, well, it's not free. You've already paid for it when you paid your fees, right? But you don't need to pay extra. Thank you, Kathy, it was important. Also, I should mention to you that I think Nadine is always on the lookout for tutors. And the further up the food chain we go, the harder it is to find people who can do that. So if you're interested in that, you might want to, what do you do? Do they just contact Nadine and ask if they're looking for tutors, or how does that typically work?
Typically, you want to go directly to Nadine. She can give you the website address to do the actual application. But
Right.
talking to her first would be a good step.
So her name is Nadine Hayes, H-A-Y-E-S, Nadine Hayes. And you should be able to find her email. I think you just say Nadine, is it nhays@olympic.edu.
Mm-hmm.
And if you forgot what I just said, look back at this Zoom meeting and you can hopefully get it. Okay, let's jump right back in. We've got no more time. Oh, that's perfect timing now. Well, tomorrow when we come, we are going to look still on sequences, right? And we're going to look in particular about finding the limit of a sequence and how to generate the formula ones. You know, like an equals n squared plus 1. How do you get the formulas? How do you create them? And we're also, as I said, we're going to be looking at finding the limit of a sequence. So you can imagine a sequence, if you kept on going, forever? Would the answer diverge off to infinity, right? Or would it home in on a number like 0.1 or a fraction like 3/4? And we're going to look at how to do that. Not that difficult actually, because you already know how to do limits from Calc 1. And we're just going to return to that piece of knowledge and show you how you can use it.